Okay, let's start our session for today. So first of all, uh, I will introduce myself, then we will discuss the course contents, and after that we will start with network basics today. And 1 day or 2 day, or maybe 2 to 3 days, depending upon your prior knowledge or something. So we spend on these basics, and then we will proceed towards the proper course content. So first of all, uh, my name is Mohammad Saqib Nawaz. I'm in the field of this computer networks for I think more than 25 years. So I have started my career with Windows 94. Then with the passage of time, I did my CCNA, CC. I did my CCA return for the first time on 27th August 2000. After that, in Microsoft, I am certified from that time to up till now. Uh, the second one thing is in Cisco certification, Cisco Cadet certification, I'm CCA certified. I have roughly all CCNP certification like CCNP Enterprise, CCNP Security. So I did CCSP back in 2008, and from then to now, I'm certified on that track. Uh, my data CCI is in data center as well. In VMware, I'm VCP and VCP data center virtualization, network virtualization, cloud automation, CMA, cloud management and automation. After that, did my workforce mobility as well, VCIX NV. Um, with, with regard to the instructor certifications, I'm Cisco certified academy instructor from 2008 to up till now. I'm for Cisco Academy. I'm the instructor trainer for CCNA, CCNP, CyberOps, etc. For VMware, I'm VMware certified academy instructor. I'm CH certified as well. See, I did my CH V10 version 10, and I'm also EC Council certified instructor for CEH as well. So in this training course, we have to cover this CCIE enterprise infrastructure. So in CCIE enterprise infrastructure, we have to cover these contents, but it is not necessary that I will follow the same sequence because we will start with the routing. Anyway, in the switch networks, we will discuss some basic switching and switch administration. Then after that, we will move towards the VLAN technologies, spanning tree protocols, ether channels, first of redundancy protocols, how we can configure the redundancy using IPv6 RSA and RA messages, or we can say it IPv6 native redundancy. Then we'll proceed in the routing section. We will discuss the routing basics, static routing, EIGRP, OSPF, BGP, route redistribution and filtering, multicast. So whatever we will study in routing especially, so we will cover with respect to both IPv4 and IPv6. In the same way, whatever we will cover, so we will try to cover IPv6 as well. So after the routing, we will have MPLS and MPLS VPNs. So we'll see what is the MPLS, what are the benefits of MPLS, and then we will see that how we can configure MPLS VPNs. What is the logic behind MPLS VPNs, how they work, etc. So we will cover some network services and optimization techniques like NTP, DHCP, NAT, IPSLA, BFT. We will discuss some network monitoring and data capture tools as well. In infrastructure security and services, we will cover access control lists, AAA, LAN security, IPsec VPNs. We will discuss simple IPsec VPNs, IPsec over GRE, static virtual tunnel interfaces, DMVPN, and then I will show you I version 2 as well. IPv6 infrastructure security features. So we will cover zone-based policy firewall. There are some other topics which will be the part of the network infrastructure security. So in the same way, we will add some more topics related to the device management, secure access. So basically, if you have some good CCNA level knowledge, and if you have studied CCNP, because I will start from very basics. If you have very good CCNA foundation and you have some experience, you understand the basics of networking, so you can join this course because whatever we will discuss it from the very basics. Even sometimes, let's suppose if we are talking about the network basics. In network basics, we will discuss IPv4 addressing, v6 addressing, network topologies, how packet forwarding. Then we will see what is the routing table building process, routing table lookup process. So these are the topics that we will cover in the network basics. If you will require some more information, we can add that. But I think these are enough if we will want to go for the advanced topics. So after this, we will have some software-defined infrastructure related topics like STXS. Welcome. So in STXS, we will discuss the basics of STXS. So in STXS, we have to understand. We will discuss first of all underlay of SDXS network, so which is ISIS. So we will discuss it. Then the overlay fabric design. So in the overlay fabric design, the control plane is Lisp, data plane is VXLAN, and policy plane is Cisco TrustSec. So we will discuss all these topics, and after that we will discuss the basics of this Cisco SDXS. Then later on, uh, before your boot camp, so we'll show you the SDXS configurations. But maybe in this training session, I will not show you all the SDXS configurations because of the DNS center, and those devices are usually used by the students who are practicing for their CCIE lab exam. So that's why, anyway, so we will show you along within this training, or maybe depending upon the availability of the rack. So we will plan it, but before your bootcamp, we will cover it. So we will discuss how we can configure the VNs virtual networks, how we can assign these SGTs using ICE, how we have to integrate this ICE with the DNS center, and how we can configure all this stuff. SD-WAN, I will show you each and everything here in this technology session. In SD-WAN, we will first of all we will discuss the SD-WAN design. After that, we will discuss its different planes. Let's go. Orchestration plane is our vBond. So management plane is vManage. Control plane is vSmart. Data plane is the WAN edges. So I'll show you how we can configure all these controllers, how we configure these WAN edges, how we onboard WAN edges onto the SD-WAN. Then the control plane of SD-WAN is relying on a protocol OMP, Overlay Management Protocol. We will discuss OMP. There are different types of routes in OMP, OMP routes, OMP T-logs, OMP service routes. So we will discuss what is the OMP, what are the OMP routes, T-log routes, and what are the service routes, and what is the best path selection criteria. Then we will discuss the SD-WAN templates, device templates, and feature templates, how we can configure the devices or SD-WAN devices by using these templates. Then we will discuss two types of policies. The first one will be the localized policies. The second one is centralized policies. So then this last section, infrastructure automation and programmability. So some other instructor. So after these technology sessions, he will give you, I think it's 2 weeks training on infrastructure automation and programmability. But this is not, I will not cover this portion. So I have to cover all this stuff which I have mentioned in these course contents. So if you have any questions related to these course contents, you can ask now. And if you would like to introduce yourself so that I can come to know your level, that I will cover all the from very basic to advanced. But still, if I know your background or your experience level, so it will be much better for me to carry on this training course. So one by one, you can introduce yourself, please.
Hello, sir. Good evening. Good evening to all.
So I'm asking you, basically, you guys introduce yourself.
Okay. Sakib, sir, I'll go first. Okay.
Okay.
So, hi everyone. Good evening. My name is Indranil Chaudhary. I have around 11 years of experience in this network background. I have worked on operation deployment stages. I have worked on maximum all of these technologies. I have like some understanding on the topics that sir showed me right now. Okay, and currently I'm working in ECI. Okay, so yeah.
Thank you.
And I have one question. I have one question here. Like, is that SDA and SD-WAN labs are going to be covered under CCIE lab section,
Yes,
or
basically
is
there
that?
is a complete section on SD portion. So there are some questions, 2 to 3 questions related to SD access and 2 to 3 questions related to SD-WAN in the
And
CCIE.
that configuration is required in the lab,
Yes, you
or
have to do the
it's a
configuration.
okay. And sir, I wanted to ask one more question. Like, I enrolled in December, and then I came to know like there are some labs scheduled in the first week of January, and I think you are busy
There is
for
no
that.
change
So
yet.
there is no change.
Hmm.
Okay, okay. Thank you so much.
Welcome.
That's all.
Oh, thank you.
Hello, sir.
Yes, please.
Hello. Yeah, you can hear me, right?
Yes, yes, I can hear you.
Yeah, my name is Jamshir. I have been in the network industry for last 12 to 13 years. So I have some experience in the switching and routing backgrounds, as well as some security appliances. I am working in Kuwait. Actually, my native place is in Kerala. That is from my side, and I just want to know what is the schedule, like how long this entire topic will be covered. As I know, it is 2.5 months. I mean 2.5 months.
Yes,
It
it
is
is
right.
8 to 10 weeks. We will cover this
10
technology.
weeks.
Yeah, technology portion.
As soon as it completed, we will start lab preparation at the
After
next
this,
day itself. How it
you will
is?
have 2 weeks of automation classes, and after that, you will have a lab preparation boot camp.
Okay. What I'm trying to ask, is there any gap between these stages, or straight it will continue in the
So
next day itself?
basically, this automation class we run once a month. So when we will be finishing, it depends whether the class is starting after the very next week, or maybe it will be after 1 or 2 weeks. So sometimes there is a it can be maximum 2 weeks difference between the
Gap.
start and finish time of each portion.
I see.
Mm.
Okay, fine. Thank you.
Yeah, hi Shakib, can you hear me?
Yes, I can hear you.
Yeah, myself, KT Narayana. I'm based out of Chennai. So I've been working on networking for last 19 years, like from stages from like you Windows to networking. I started with my career in Windows and then moved to the networking. So we have knowledge on these topics, but the SD-WAN, we have worked on VMware technology. So Cisco is a new platform to me. So I wanted to learn SD-WAN and Cisco, and want to achieve the CCIE. It's like a dream. So I attempted the CCIE routing and switching 6 years back, and then I failed in the troubleshooting part, and I didn't try for the second attempt. So
Okay, so
it's
this
just an
time
ambition to.
hopefully you will pass your lab exam, because we will prepare you according to the requirements. So don't worry about this. Just follow the lectures.
Yeah, Sure. I was a student of Siddiq sir actually in the advanced boot camp in Hyderabad. Yeah, that's about me.
Thank you.
Hello everybody, can you hear me?
Yes.
Myself Sobin Peter. I've been working in the field of networking and security for the last 11 years. I'm working in Muscat, and I was enrolled in your previous batch. Then unfortunately I couldn't continue due to some personal reasons. So that's why I've rejoined again in the same batch.
Thank you.
Good evening, sir.
Hello. Yes, please.
Sir, I'm Kumar Swami. I'm CCNA certified. Actually, I'm working in BSNL from past 13 years in telecom domain. So I enrolled for this program for CCIE certification in EI.
Nice. Yeah.
So
So don't worry. Basically, we have to discuss each and everything. So because sometimes we will have uh, get some trainings, but they forget some stuff, or they are not used to, or they are not using each and everything in their environment. So that's why, um, if you know something, maybe it will be something refresher, or maybe you will get some new information from this training. So I will use Paint. I'm not going to use any slides. So I will explain each and everything in Paint, and we will use GNS3 for routing labs, MPLS labs, and then we will use EVE-NG for some advanced labs like SD-WAN, some switching labs, and those stuff. If I will have to show you something in data capture or something, I can use packet tracer as well, but it will be only for 2 to 3 lectures. So most of the time we will spend on. Yes, please.
here I have a question.
Yes.
Actually, what are the system requirements to complete the CCIE?
If we include SD-WAN, so then your requirement is 32 gigs of RAM. If we are talking about other than SD-WAN, then 16 GB RAM is enough. So
Okay,
Core
thank you,
i5
sir.
or anything, Core i5 plus is good.
And Sadiq, how much DNAC will cover in this training?
This training will be covered in 10 weeks totally.
No. I mean, how much depth we cover for SD DNAC? Like we'll go all the topics, or only will touch required for the CCIE exam, or how is that? How much we cover on
I
the?
will explain all the planes. I will explain all the components of the SDXS, and in the lab, we cannot do a lot, but we will explain each and everything. But I can show you some specific configurations which are supported in that rack environment. So we cannot say like that we are gonna uh, anyway, but if you think it in a way like we will show you that how to integrate DNAC with the ICE. We'll show you how to onboard or provision the switches, then how you configure the virtual networks, DHCP pools, etc. So, and how you can even configure the specific ports for specific systems. Or so roughly we'll show each and everything. But if you are talking about very advanced topics like the CCI lab exam, we have to integrate it with SD-WAN. So we'll cover up to that portion, but there are some other deployments, like sometimes you have multiple sites, so multiple site connectivity or something. That portion will not be covered. So for with respect to one side, we'll cover roughly everything.
Okay, so to reach the exam level, we'll cover all the topics.
Yes, it is. Yeah, whatever you have to do in the exam, we'll cover all those things. So when you will be going for your exam, you haven't good knowledge about each and everything, whatever you have to do in the lab exam.
Okay.
It will not like that. We are just going to prepare you for the dumps, so you will understand the concept.
Okay.
Second,
Yes, please.
just want to know, after each class, daily classes,
Yes.
what we get, like, we get any short notes, pre-prepared
I will share
notes,
these paint
videos?
files in the WhatsApp group. Then I will send the recording of this each class to the NetMetric. They will upload it on their server, and they will share the portal access credentials, so you will be able to access these recordings.
Now, other than the video, any notes or short notes
Yeah, I will
like
send
that?
you these paint files, whatever we are using here. So I will share these paint files.
No, not any documents. No, only
Documents
this
or books.
video and
Basically, if you have an core book and an RC book, so you can go through them. Otherwise, I always prefer to follow the Cisco website. So let's suppose in the CCIE lab exam, if we have some specific iOS requirements, so you just go type that iOS name and then the topic name. So it will give you much more information that you can find anywhere else.
yeah, but precisely what we need for this, to cover the blueprint. That's what the content for the blueprint that is required now. If we go to Cisco website or any other website, we have a lot of
Basically,
information. That
whatever
much not required.
whatever is in the blueprint, I will cover and I will write here on the paint in the paint file. So I'm not gonna type so much theory. Whatever is required. So if you will have that in knowledge, if you know that concept, so it is enough. And then I will show you each and every configuration. I will copy those configurations in the paint file as well. In this, if some show verification commands output is required, I will copy that into the paint file. So I will make the complete notes for you.
And after the theory, the
Yes.
practical labs, technology practical labs.
Technology
So for
practical
that
lab.
scenario and all, how we get and all.
So basically, are you added to some WhatsApp group by NetMetric or?
Not yet, not
Okay,
yet.
they will do it today. So these questions you can ask in the group from Sushant. He will be there. Ali will be there. They can tell you exactly what is their commitment regarding to the lab access or rack access.
Sir, I have one question. Are you going to provide any study material or whatever the things that you are going to do here that is going to sufficient for this lab exam? Or is there any some practice questions or some brainstorming thing? Are you going to provide these things?
So basically, when you will go through the boot camp training, so you will get all the materials related to the lab exam. So when you have to pass the NCORE, which is considered as a CCA written exam, so uh, NetMetric will provide you those sample questions or brain dumps or something, whatever you want to call them. The second thing is with respect to my portion or my segment, I'm telling you that I can share the paint files. You will have the video recording of the lecture. If you need the GNS3 file or whatever the lab, I can share that with you. So this will be from my side. So if you
Okay.
want to read in more detail, something in more detail, so then you just have to follow the Cisco website. So Cisco website will, if you will, if you would like, I will show you that how you have to find something uh, related to some specific protocol or something. So there will be explained, given each and everything. So sometimes in the books you cannot find out all that stuff. So that's why I will recommend that instead of searching for some other material, some other websites or something, it's better to follow Cisco website. Yes, when those dumps will be stable, you will be provided.
Okay. And one more thing, Jay, like you mentioned that you are going to use GNS3 and EVNG as well. I
Yeah.
mean, is there any specific difference between them? Actually, I have a EVNG already, set up in my
You,
laptop.
you
So,
can use
is
even
there any specific?
basically when I have to deliver the training. So my laptop, I have to run the lab environment. I have to run this meeting. I'm recording on the same machine. So sometime voice starts breaking. So what are the
Oh,
labs which are possible on GNS3? I do it on GNS3 because EVNG requires some more resources. You can do the same
I
thing
got.
in EVNG, no problem.
Okay.
In EVNG, use VIOS switch, VIOS router, and you will be able to do each and everything in the same line.
May I get that image? I mean, like BIOS actually. Actually, I have that one. Okay, fine. That
If
L3
you
image
will
I
not
have.
have, we will share with you. Don't no problem.
Okay, thank you, sir.
Um, so first of all, let's start with some network basics. In network basics, we need to understand the packet forwarding. So packet forwarding, uh, let's suppose we have three different networks, two routers connected to each other. Using point-to-point link, then we can have some devices in our network. So these devices or end systems are connected to the switch, and then let's suppose if we want to communicate outside of the network, then we can have a router. The third possibility is, let's suppose we have multiple routers or multiple branch offices which are connected to each other through some WAN service provider or WAN. So how these devices communicates to each other. So can anyone explain the differences in communication on all these three networks? Any idea, or the communication will be the same?
First one is point to point.
Okay.
The last one is hub and spoke.
Okay. So how
So
the
made on industrial architecture enterprise.
so how we can differentiate between the communication? Let's suppose R1 wants to send a packet to R2. What are network topologies?
And frame relay. First one,
Network topologies.
bit topology.
How many network
I mean, it's a,
topologies about?
Star, hub and spoke.
Okay.
yeah.
No.
So yes, any other topologies?
Packet switching, circuit
Mesh,
switching.
no, mesh topology, star topology, and
Hub and spoke.
Okay.
hub and spoke. Yeah.
Okay, let's divide the network topologies into three types. So we say we have three types of network topologies. The first one is called as point-to-point.
Point to point star bus.
The second one is called as broadcast
Star
multiple access.
broadcast.
Broadcast.
The third one
Again,
is
and this
called
one
as non-broadcast
non-broadcast.
multiple access. So basically, these are three network topologies, and these network topologies are defined on data link layer of OSI model. So this topology defines the packet forwarding behavior on these networks. So let's suppose if this is R1, this is R2, it is connected to these two devices are connected to each other on a point-to-point link. So point-to-point link means if I show you another point-to-point link, So now these two routers are connected on Ethernet ports. It can be fast Ethernet, gigabit Ethernet. So is it the same communication or there is some differences?
It is different because encapsulation is different.
Yes. So basically, this one is point to point. This one is not point to point topology. This is point to point link. So this is also point to point link, but this is point to point topology. This is not point to point topology. So that's why let's bring it here. So first of all, when we say the point to point topology, the first requirement is for point to point topology, your base network must have to be a circuit switch network. So circuit switch networks, we have three circuit switch networks. The first one is uh, POTS, plain old telephone system. The second one is PSTN, public switch telephone network. The third one is ISDN, integrated services digital network. So these three networks are called as circuit switch networks. So why we call them circuit switch networks? Let's suppose we have two telephone exchanges, and these two telephone exchanges are connected to each other, and then we have one line going towards our customer site, and these two routers are connected here. So if all these circuits are analog, then it is POTS. If end user lines or circuits are analog, but the circuits between the telephone exchanges are digital, then that is called as PSTN. And if all the circuits becomes digital, that is called as ISDN. So this is purely analog. This one is purely digital. So this one is analog and digital, combination of analog and digital circuits. So basically, let's suppose this is telephone exchange 1 and this one is telephone exchange 2. So this one is router 1. Router 1 is connected on telephone exchange 1 line 1, and this router 2 is connected on line 1 of telephone exchange 2. So now this user's number is 11, and on the other end this user's number is 21. So when 11 will dial 21, the call will reach to the telephone exchange 1. It will look for the destination telephone exchange number, which is 2. So then this call will be switched with the circuit going towards telephone exchange 2. Then the call will reach to telephone exchange 2, and it will be switched with the circuit going towards number 2, 1 or 1. So in this way, we have switched three circuits to establish a point-to-point connection. Now, if anyone else wants to communicate with 1, 1 or 2, 1, so he will get the busy tone. Because on the point-to-point circuit, we can have only two systems that can communicate at a time. So this is called as circuit switching. We are switching the circuits. In the same way, this was the example of a simple example of circuit switching. So when we will discuss the media access control method, so I will elaborate the communication on the digital circuit, that how the communication is happening on the digital circuit between the telephone exchanges. So if we are using any of these service providers, then it means our topology is point to point. So let's suppose the second thing is, if we are using this point to point topology, then we can have some encapsulations. So, and the first encapsulation, default encapsulation on Cisco devices is HDLC, and the second one is PPP. So HDLC or PPP, these are the two encapsulations which we can use in this topology. The third one is physical address. On layer 2, another important feature is physical address. So because in the layer 2 header, we need to add physical addresses or physical address. In this case, physical address is not required because the two devices are communicating to each other. So the concept is like two people communicating to each other. They do not need to address every time. So they just broadcast. So there is only one receiver. In the same way, if this router will broadcast something, it will be received to only one receiver. That's why there is no need for physical address in this topology. So physical address is not required. Let's suppose if you need physical address on serial interface. So which Ethernet address will be used? This is my router, and this router requires something because of which I need some MAC address. So which MAC address will be used on serial interface? MAC address of the
Serial
lowest interface
MAC
IP.
address is not there.
It's not there, but let's suppose if you are using something like PPPoE or something, so you need to use some MAC address on this interface. So it will use the, let's suppose if you have two interfaces, fast Ethernet 0 by 0 and fast Ethernet 0 by 1, or gigabit Ethernet 0 by 0 or gigabit Ethernet 0 by 1. So the MAC address of the lowest Ethernet interface is used on the serial interfaces. So then there is another thing which is called as logical to physical address mapping. Logical to physical address mapping is required when you have multiple access. Multiple access means you can communicate with multiple destinations by using a single physical connection. So that's why you need two addresses, logical and physical. In this case, let's suppose if we configure this router and I set an IP address 10.1 and I will set an IP address on 10.2. So we do not, there is no any MAC address, so there is no any physical address. So that's why we do not need any logical to physical address mapping. We just put a broadcast address into the header and forward it to the destination machine. So logical address to physical address mapping is not required. So you don't need anything like our. Then media access control method. So media access control method is TDM, time division multiplexing. Media access control method will define how we can provide multiple systems act with access on the same circuit at a time. Let's suppose this is our telephone exchange 1, this is our telephone exchange 2, and these are connected to each other on a digital circuit. So let's suppose these are connected on T1 line. So analog circuit bandwidth is 64 kilohertz. So if we convert this 64 kilohertz into digital circuit, so that is called as DS0, digital signal 0. And digital signal 0 has the same bandwidth, but it is in kilobits per second. So 64 kilohertz, 64 kilobits per second. Then we have some more lines, T1, T3, etc. So when we are talking about T1 line, so T1 line is equals to 24 DS0 circuits. So these 24 DS0 circuits are the logical circuits. So that's why now we have to show that how 24 calls are possible, because one call needs the bandwidth equal to 1 DS0. If we have 24 DS0, it means we can communicate 24 calls on the same circuit at a time. So how those 24 calls are possible on the same circuit at a time? So this will be defined by using this time division multiplexing. So let's suppose if we are talking about this network, on this network we communicate the data in the form of T carrier frames. So this T carrier frame is divided into 24 slots. So first slot, second slot, and then 24th slot. So we can say this is first DS0, this is second DS0, and this one is 24th DS0. So each slot size is 1 byte, 8 bits, 1, 2, 3, 4, 5, 6, 7, 8. So each slot can carry 8 bits or 1 byte of data. So if we tilt this frame here, so now this is our first DS0, This is our second DS0, and this is our 24th DS0. So if we receive a call from line 1, so we can switch it to one logical channel or one logical DS0. If we receive a second call, we can switch it with the second DS0. If we receive the 24th call, we can switch it with this 24th DS0. And if we move this frame in the same way to the, sorry, on the same link, so when it will reach here, so then it can be switched with 24 different circuits. So that's why we are saying that we can have 24 calls at a time on this line. So this thing is called as T carrier frame, and 8,000 T carrier frame per second are communicated on this network. So in 1 second, one slot is carrying 8 bits. So 8,000 into 8. So it equals to 64,000. What 8,000 into 8 bits. So 64,000 bits per second. And we can call it as 64 kbps. So now we have 24 channels. So there is one framing bit. So 8 into 24, it is 192 plus 1, 193. 8,000 into 193. So it is equals to 1.544 Mbps, which is the bandwidth of this T1 line. So if we are using ports PSTN, ISTN, so in that case we are having this point-to-point topology. The second one is broadcast multiple access. Multiple access means so when we communicate with multiple destinations using a single physical connection. Is called as multiple access. So this one is broadcast multiple access, a multiple access network in which broadcast is allowed. So then that will be called as broadcast multiple access. So the first point is it is packet switch network. If we do the circuit switching, it is not possible to communicate with multiple destinations using a single physical connection. So packet switch network, the first thing is, so packet switching is when your device takes a decision based on the header information. So let's suppose this system is 1.10 and its MAC address is A. Then the second system is 1.11, so 1.12, and their MAC addresses are B and C. So this system is connected on port 1, the second one is connected on port 2, the third one is connected on port 3. So now the switch will maintain a table in which it will put that the MAC address A is connected on port 1, MAC address B is connected on port 2, and MAC address C is connected on port 3. So now if this PC1 wants to send a packet to PC3, so it will put the MAC address 3 in the destination MAC field. So when the traffic will receive to switch 1, it will look into the switching table. So switching table will tell that C is connected or reachable on port 3. So then the traffic will be forwarded to port 3. So this is called as packet switching. So when your switching device takes the forwarding decision based on the packet header, so that is called as packet switching. So this is packet switch network. So in this packet switch network, we can have an encapsulation which is called as Ethernet. So then in case of the Ethernet, so this is Ethernet header. In the Ethernet header, the first field is called as destination MAC, the second field is called as source MAC, and the third field is called as type. Source MAC, destination MAC, and then type. So it means we need some physical address. So because we have to put the source and destination addresses, the physical address is required, and the physical address used in this in Ethernet is MAC address. So when we have both addresses, logical to physical address mapping is required. So logical to physical address mapping is ARP, address resolution protocol. In case of address resolution protocol, let's suppose each system will have will maintain a cache which is called as ARP cache. So these are the two systems. Or let's add another system. So these are connected to the same network. So this system is 1.10 and the MAC address is A. This one is 1.11 and MAC address is B. So this one is 1.12 and MAC address is C. So all these systems maintain a cache which is called as ARP cache. So if you want to see this ARP cache, you can use ARP-A on the system, and then you can use show ARP on the router. So this ARP cache will store the IP to MAC bindings or mappings of other systems on the network. Let's suppose if 1.10 wants to communicate with 1.11, so it will look into the ARP cache that it contains the 1.11's MAC address, so it is not there. So what it will do, it will generate a packet which is called as ARP request. So let me quickly show you here. So this is your one system. Is there any other use of ARP other than this IP to MAC binding? So do we use it for any other purpose?
Yes, for duplication of IP address, GRP will be
Yes,
used.
it is used for duplicate address detection. Why we use subnet mask?
To define how many network bits, how many host bits is it.
What is the benefit of it? Is there any benefit? Why we need to know?
To split the broadcast domain.
Okay, so let's suppose this is PC2. How it will benefit PC2 to split the broadcast domain? How it will impact on the packet forwarding?
Because in a network there are more than if a broadcast is sent, it will go to everywhere, no?
It depends on the on which port which VLAN is configured. So accordingly, the broadcast will be forwarded under that VLAN only. So subnet mask is it is defining the network bits and host bit from a particular address, right?
It's true, but the main purpose is if there is no subnet mask. So let's suppose if Thus, this system PC1, PC0 is having an IP address of 192.168.1.10. So if in its network there are only 2 systems, or if there are 1000 systems, is there any difference for in its communication? So broadcast is, let's suppose if this one it will generate. So how, whatever the number of systems available in your network, all those systems will receive that broadcast
Yes.
message automatically. So this is your duplicate address detection. So first of all, source IP is 192.168.1.11, target IP is 1.11. So it knows its own MAC address, but it is asking it if anyone else is using the same same IP address, so send me your MAC address. If it will receive the response, it means someone else is using this IP and it is a duplicate IP, and then it will change its IP address. So let's suppose if we are assigning by using the DHCP, it will send a request to the DHCP to renew it. If we are using the static IP address, it will not allow you to configure it by giving you an error that duplicate IP address on the network. So now this R packet is forwarded to all systems on the network, so no one else is using the same IP address. So that's why this ARP request is discarded. So this is your duplicate address detection. So now in the same way, let's suppose so the same way 1.12 is doing the same thing, duplicate address detection. So let it go. So now this system, first of all, let's suppose we have 2 systems or source IP. Source IP is 192.168.1.10. Destination IP. So destination IP is 192.168.1.11. So if we will say ping 192.168.1.11. Hi, welcome. Basically, we are just discussing some network basics. So you will get the recording. So don't worry. Try to be in time in the next classes. It's okay for today. So the subnet mask is 255.255.255.0. So this system will multiply its own subnet mask with the IP address. So it will get the network ID 192.168.1.0. In the same way, now it will multiply the destination IP address to its expected subnet mask. So this time it will get 192.168.1.0. So when the source IP is multiplied to the destination, sorry, subnet mask, and destination IP is multiplied into the subnet mask, so we get the same network ID. It means the destination is located within the same network. So when the destination is located within the same network, it means that your system will have to look into the ARP cache for the MAC address of 1.11. But in this case, there is no any MAC address of 1.11 in the ARP cache. So that's why now this system will generate the ARP request to get the MAC address of 1.11. So when it will communicate with 1.11, 1.11 will return its MAC address B. So now this system can put the destination MAC address B and send the traffic to system 1.11. If let's suppose we say the source is 192.168.1.10, but let's suppose our destination is changed this time. So source is same, but the destination is 192.168.2.10. 255.255.255.0. So when we multiply destination IP to its subnet mask, so it will become 192.168.2.0, which is the network ID, destination network ID. So now your operating system compares the source network ID with the destination network ID. If it is not same, if it is different, so then it means the destination is not located within the same network. And when the destination is not located within the same network, it will look for the system routing table. If the system routing table will have the route, so then it will come to know, let's suppose I have PC0. On PC0, if we go to command prompt in the IP configuration, I haven't provide the default gateway IP address. So this time we will say netstat -r. So this is the system routing table. In the system routing table, there is no any route because we haven't configured or we haven't provided the default gateway address. So it means if we want to allow the system or if we want the communication with the remote destinations from this system, we have to provide the gateway address. So now we will tell it that if you want to communicate without any destination outside of the network, so your gateway is 192.168.1.1. So when we provide the gateway IP address and we see the routing table again, so this time you can see a route is added. So whatever the destination network ID other than the local network, whatever the subnet mask other than the local subnet mask, send it to 192.168.1.1 through the interface 1.10 and put the TTL value of 1 in the IP address. So because of this route, so now the system knows that for the remote destination, I have to send the traffic to 1.1. So after looking into the routing table, now it has the IP address of the next hop device 1.1, and it will look into the ARP cache. So this decision is taking based on subnet mask. So that's why we are using subnet mask. So system routing table and then ARP cache. So these are the two tables for remote communications. So if the communication is remote, so your operating system looks into the system routing table. If you want to see, the command is netstat-r and then the ARP cache to get the gateway MAC address. So ARP-A. And if the destination is communication is local, local communication means source and destination network ID is the same. So then it will look into the ARP cache for the destination MAC address. If it is there, well and good. Otherwise, it will send the ARP request. So this is the use of subnet mask. So this is PC0. So we go to command prompt. In the command prompt, we will use ARP-A. So there are no ARP entries. So this time we will say ping 192.168.1.11. So now it will generate the ARP packet. So this is the ARP request. If we open it, so we will discuss this field a little bit later on today. So this is the destination address. So destination address is broadcast MAC address, and this is the source MAC address. Source MAC address is the sender address. Then you can see the OP code is 1. This is your ARP request, and then it says the source MAC is this one, source IP is this one. This is the target IP, but the target MAC is required. It's unknown. So that's why when the switch will receive, because the destination MAC is broadcast, it will be forwarded to all systems or all ports except the originating port. So now this system is having some other IP address other than 1.11. It has discarded, but now this system is going to send the ARP reply. It is saying I am 1.11. This is my MAC address, and I'm going to send it to 1.10 with the MAC address this one. So this ARP reply is OP code 02. So now this ARP reply will be forwarded to the switch. Switch will send it to the PC0 or 1.10 only. So now this system will have it can communicate So now it has the mapping of 1.11 and its MAC address in the ARP cache. In the same way, if we will say ping 192.168.1.12, so now we have both mappings into the ARP cache. So sometimes we see it 128, sometimes we see it 64, sometimes we see it to 255. So why we are getting these different values?
Based on operating system.
Yes, it's true. So basically, okay, explain the operating systems as well. If someone don't know, so for his knowledge.
It's a 128 for Windows operating system.
Okay,
64 is a Linux operating system.
okay.
If it
And
is a Cisco router, 255. TTL is 255.
yes, so basically, if you are pinging to some Cisco device, it will respond with 255. If you are pinging some Microsoft, so it will return with 128. And if you are pinging some open source machine, so then you will get the TTL 64. So will I get every time we will get 64, or there will be some change value other than 64? Let's say if I'm getting 56, what does it mean?
It crashes 64 minus 56, that many routers,
Yes. So basically,
that many hops.
on each hop, this value decrement by 1. So if we send a ping message to 888 or Google, so then the traffic will be forwarded to will cross some routers or some hops. So when we will receive the response, so if the Google server is using Linux operating system, it will start with 64. The first device will decrement it 1, it will become 63, then next 62, and maybe if it is 8 hops away from my machine, so then it will show me 56. It means that device is 7 to 8 hops away from my machine.
So one thing, when it is sending the ARP request to the
Yes.
broadcast, I mean, the ARP max should be all F, right? Why it is showing as 00?
Uh, Basically,
Oh,
you are different. There are two different things. Let me make it clear. ARP-D. So this command is used to clear the ARP cache. So now I'm gonna send it ping to 192.168.1.11. So let it send to the destination machine. So let's suppose this is our ARP packet. So there are two different things. One is Ethernet header. In Ethernet header, destination is FFF. So this is the
okay.
header information to which this Ethernet frame will be
Yeah,
forwarded. And we need to get the MAC address of 1.10, so that's why we put 000. So this is the requesting IP and MAC, and this is the Ethernet header destination MAC address. So
yeah.
what is this preamble
That's right.
field? Anyone know about preamble? Okay, let's discuss it. The fifth point, media access control method. So media access control method is carrier sense multiple access over collision detection. SISMA CD. Carrier sense multiple access over collision detection. So how it works? So basically, let's suppose this is a hub, because in switches we have this multiple collision domains. So that's why we cannot understand it properly. So that's why let's suppose it is a hub. And these devices are connected to So this system is A, this system is B, this system is C, and this system is D. So on Ethernet networks, whenever a system wants to initiate the communication, so the first step is it will sense for the availability of the media. So if it will detect some communication, so preamble field is carrying the time synchronization information that the current system who is currently communicating on the media, so how long it will take to complete its communication. But if it does not detect any communication, then it will send the carrier signal. So carrier signal is a very light signal. So this signal will be forwarded over the network. So when the signal will be forwarded over the network, now this system or the sender machine is waiting to receive a noise signal. If this carrier signal will collide with some other signal, then noise signal will be generated. But let's suppose if it will not receive any noise signal, then it will start sending the data. So it is your smooth communication, and it will put in the preamble field, I need these time slots to complete my communication. If some other system will sense and it will detect the communication is happening over the network, and it will read the preamble field value and will go to the backup state for that time. So let's suppose this A was sensing and A has generated a carrier signal. At the same time, this D was also sensing and the media was available. So this D also has generated the carrier signal. So these both signals collide at this point. So in the result, a noise signal will be generated, and that noise signal will be forwarded to all these machines. So when the noise signal will receive, each system will execute an algorithm which is called as backup algorithm. Backup algorithm. This backup algorithm will assign a value of backup timer. So A system initiated the communication and received the noise signal after a large number of time slots. So then it will assign itself a lower backup timer value. So B was not communicating, so that's why it will assign a higher value. C was also not communicating, so it will assign a higher value. D has initiated the communication and received the noise signal, so it will assign a relatively higher value. So 1 millisecond, 9, 12, and 3. And until this timer value is valid for that time, these devices will remain in backup state. So these devices will remain in backup state. So first of all, this 1 millisecond A's backup timer will expire, and it will come out of the backup state, and then it will sense and generates the carrier signal, and that carrier signal will be forwarded and will not face any collision, and after some time it will start sending the data. So if two carrier signals collide to each other, that is called as early collision. If a carrier signal collides with the data, it is called as late collision. So in the result of the early collision, they assign the lower values. In the result of the late collision, they assign the higher backup timer value. In our case, because we have a small network, so though both carrier signals collide to each other, so that's why they assign these values to each other. So that's why we say carrier sense multiple access over collision detection is the media access control method But because nowadays in the switches we have multiple collision domains, so each switch has its own multiple collision domain. Even the switch has separate RX and TX, so that's why there are no any chances of collisions. The third topology is non-broadcast multiple access. So why broadcast is allowed in this topology? Because this ARP requires the broadcast, because the first ARP request packet is broadcasted over the network. If we will stop the broadcast, so then ARP will not work, and when ARP will not work, we won't be able to get the destination MAC address, and communication will not be possible on this network. So this one is non-broadcast multiple access. I'm just going to write down some points. The first point is, again, it is a packet switch network. The second is encapsulation. So we can have X.25 frame relay, ATM. So these are the possible encapsulations. So the switch will forward the traffic based on X.25 header will be called as X.25 switch. In the same way, frame relay switch, ATM switch. So because it is multi-access network or multiple access network, so that's why physical address is required. So for X.25, it is X121 address. For frame relay, it is DELC, and from ATM, it is NSAP. So these are the physical addresses used for these encapsulations. Logical to physical mapping is required. So the logical and physical mapping method used here is, I'm just going to put a generic name. It is called as inverse R. Inverse R. So otherwise there is X.25 map, frame relay map, ATM map. So these are the static options. Inverse ARP is the dynamic option. The fifth one is media access control method. So media access control method is statistical time division multiplexing. Statistical time division multiplexing. STDM, TDM. Let's suppose when we consider the example of the traffic signal. On traffic signal, it is TDM, time division multiplexing. So let's suppose they have divided 2 minutes or 1.5 minutes, or sometime if there is a huge traffic volume, they can divide 3 minutes between the traffic coming from 4 different directions. So that is your TDM, time division multiplexing. So when you will reach to the signal, if it is green, so then you can cross the intersection. Otherwise, you have to wait for your valid time slot. So that is your time division multiplexing. Statistical time division multiplexing, let's suppose you reach to the same signal at the midnight. So then you will see there is no any traffic coming from other side. Then you will see on which side it is green. Then you will see whether the traffic is coming from that direction. If the traffic is not coming from that direction, you just use that side's time slot and cross the intersection. So that is called as statistical time division multiplexing. Let's suppose the service provider is having multiple customers. One customer requires its bandwidth or its services during the daytime. The second one is some call center, so that is working according to the US time or something like that. So they have different communication needs. So if they will buy some specific bandwidth, let's suppose their actual requirement is 4 megabits per second, but service provider asks them to buy 2.5, 2.5. So if because the peak hours are different, so we say, let's suppose when the enterprise network will require the bandwidth at that time, data center will not be using its bandwidth. So the service provider, sorry, if we are using this non-broadcast multiple access network, so then the enterprise network can use the bandwidth of call center. In the same way, uh, during the night time, call center will require its more bandwidth, and enterprise will be using some minimum bandwidth. So bandwidth will be available. So call center will or can communicate on 4 megabits per second. So this is how we manage that. If we need we want to get the benefit of some extra burst or extra traffic to communicate over the network when it is required. So then we go for these STDM or statistical time domain multiplexing based networks. But nowadays everything is moved to new technologies. So that's why we will not discuss these X.25 frame and ATM in more details. So let's discuss some addresses. So when we are talking about these addresses, uh, first of all, MAC address. What is the size of MAC address?
128 bit.
MAC address.
64.
48.
48 bit.
48 bits. So we write down these 48 bits in the form of hexadecimal numbers. So one hexadecimal number is 4 bits. It means 48. It will be 12 hexadecimal numbers. So MAC address is 48 bits and is written in the form of hexadecimal numbers. So let's suppose if we write down a MAC address 0000, then let's suppose 11223344. So this is a MAC address. So we can divide this MAC address into two portions. The first portion is called as OUI, and the second portion is called as vendor assigned. So OUI is assigned to the vendor by IEEE as their registration number, and they can use it um, as the first 24 bits of their device MAC addresses. So this vendor assigned is the serial number of the devices manufactured by the vendor. So IEEE cannot assign the same OUI registration number to more than one vendors, and the vendor cannot assign the same serial number to more than one devices. So that's why we call it as it is a unique address. So MAC address is also called as, there are some other names. So type is physical address and is also called as BIA, burnt in address, because it is written into the ROM and it will remain attached with the system. So there are three valid formats. We can write down in the form of this one 00011223344. So this format is used by Cisco 00 colon 00 colon 11 colon 11 colon 22 colon 33 colon 44. So this one is used by Linux, Unix, or open source. The third valid format is 000011223344. So this one is used by Microsoft. So these are the three valid formats to write down the MAC address. So unicast MAC addresses, multicast MAC addresses, and broadcast. So unicast MAC address is all MAC addresses starting with 00, or nowadays you can call it as with other one, but we'll keep it to 00. So starting with the 00, these are called as the unicast MAC address. Starting with 01, these are the multicast MAC addresses. So we use 01 and it is 005E. So the addresses starting with 01005E. So these are the multicast MAC addresses. And then the broadcast MAC address if all the values are F. So then this one is called as broadcast MAC address. So unicast MAC addresses are assigned or are attached with your network interface card. But for the multicast MAC addresses, let's suppose if we have an IP address 226.111, so this is an IP address. So we have to separate the last 23 bits. So for one, this bit will be 0. So now I'm going to separate the 23 bits. 1, 2, 3, 1, 2, 3, 4. So this is your 1 dot 0, 0, 0, 0, 0, 0, 1 dot 0, 0, 0, 0, 0, 0, 1. So I have just converted the last 23 bits into binary. So now I will add 01-00-5E as the 24 bits, and then I will convert these values into hexadecimal number. This 30 I will write on 0, 30 and 1, so it will become 1 dash again 01 dash 01. So in this way we can calculate the multicast MAC address from the multicast IP address. The last 24 bits are used in the 24 bits of the vendor assigned portion of the MAC address, and this OUI is used for the multicast MAC addresses. IP addresses. So in IP addresses, first of all, IPv4. IPv4 address is 32 bits. And is written in the form of 4 octets. Separated by dot. So IPv4 addresses are divided into 5 classes. I'm just gonna put the start and end of the class range. So if you have any confusions, you can ask. So first of all, let's start with class A. If the first bit is fixed to 0, and then remaining bits 1, 2, 3, 4, 5, 6, 7. So it will become 1. So first of all, when we are talking about the first address, which is 000, it is called as unspecified address. So then class A, if the first bit is 0, so and then 1, it is 0001. If the first bit will remain 0 and rest of the bits are changed to 111. So it will become 127. So it means if in the first octet you can see the value from 1 to 127, so then the addresses, so these addresses belongs to class A. So Class A, let's suppose if we say 10.001, so this is an IP address. So if the first octet value is 10, it is from 1 to 127, it is class A. So for class A, default subnet mask is 255.0.0.0. So this default subnet mask, the network portion bits are shown as 1 and host portion bits are 0. So this is the default subnet mask for class A. It means in class A, the first 8 bits belongs to network portion, and the last 24 bits belongs to host portion. So IP address is divided into two portions, network portion and host portion. So in class A, 8 bits belongs to network portion and 24 bits belongs to host portion. In the same way, in class B, the first 2 bits are fixed to 0, 1, 1, 2, 3, 4, 5, 6. So it is 128. And then if we keep the first 2 bits fixed to 0, 1, and then the rest of the 6 bits are set to 1, so then it is 191. So if in the first octet we see the value from 128 to 191, so then it means it is class B. Let's suppose 172.16.0.1. So this is an IP address from class B is 255.255.0.0 is the default subnet mask. So in class B, first two portions or first two octets belongs to the network portion, and the last two portions belongs to the host portion. The third class is class C. So in class C, the first 3 bits are fixed to 001. If 1, 2, 3, 4, 5, next 5 bits are set to 0, so it will become, sorry, I made a mistake. It is 10. So these are fixed to 10, not 01. So 110. So then 1, 2, 3, 4, 5, 110, 1111. So 192 to 223. So 192.168.1.0, 255, 255, 255.0. 3 portion belongs to the network and 1 portion belongs to host. What is network ID? What is IP address, and what is the broadcast ID? How you will define the network ID?
First address, network ID is the starting address of that one. Broadcast is the last.
Yes, it is the first and last is true, but let's make it if all host portion bits are 0, so then it is called as network ID. If all host portion bits are 1, then it is called as broadcast ID. And the IP address is combination of ones and 0 and ones. The combination of zeros and ones is called as IP address. So first IP address is network ID, last is broadcast ID, so all rest are the IP addresses too. So What is the private address range for class ABC?
And 000 1 16 192 168.
So what are the slash values? For the
Slash
private
8
8
slash 8
slash
slash 16
12.
12
to
and this
12.
one
This one 24.
16.
16.
16.
So
Okay.
this is the private address range. So what does mean by 12? So let's suppose it is 172.16.0.0. So I'm going to write down 16 because 12 is somewhere between this 16. So this one is your 128, 64, 32, 16, and then it is your 8, 4, 2, 1. So this is your 16.0.0. So if we keep the first 12 bits as it is, so then we can write it as 172.16.00 slash 16. So if I will change this one bit to 1, so this time it will become 16 plus 1, 17. But first 12 bits are same. And if I keep on changing, and in the last one, if I make all these 1, so then it will become 172.31. So these 16 networks are private, starting from 172.16.00/16 to 172.31.0016. But when we integrate, we can see the first 12 bits are same. These last bits we are keep on changing. These belongs to the network portion, but we can change them. So all the resulting networks will be private. So from 172.16 to 172.31. So this is the private range for class B. In the same way, when we are talking about class C, 192.168.0.0. So if we keep on changing it to 192.168.1.0, 192.168.2.0 up to 192.168.255.0. So all these are /24 networks. So if you will keep on changing the third octet value from 0 to 255, all 256 networks are private. So the common thing is 16 bits, 192.168. So that's why we write it as in this form, that all the addresses with the first 16 bits equals to 192.168, all are private addresses. So these are the private address ranges in different classes. Do you know about any special use addresses?
APIPA.
Yes, Apipa. So let's start with class A. In class A, 127.0.0/8. So this network is reserved for loopback. From class B, 169.254.0.0/16. It is called as a PIPA, automatically assigned private IP address. So when your system gets this address,
DHCP failed to get IP address.
DHCP failed to, it's correct, it's right. So we have two types of network interface cards. The first type is called as non-PXE client. The second one is called as PXE client, PXE pre-execution environment. So the network interface cards which are boot capable, so those are called as PXE clients. And the network interface cards which are not boot capable, so those are called as non-PXE client. So when the non-PXE client will send a request, so it will be DHCP request, and it will become DHCP client. So this network is called as, it is reserved for DHCP clients. It was purchased by Microsoft, and then they will make it available for everyone if for the use of DHCP clients. So that's why if you are using non-PXE client and you select get a IP address automatically, or obtain a IP address automatically, so then it will use this IP address to send the request or to communicate with the DHCP server. But if your network interface card is PXE client, so then it will send a request with 0000 to DHCP server. If it will not found the DHCP server, then it will get this IP address. So this is a little difference. So you must know about. But nowadays, all network interface cards are roughly PXE clients. So if you are using some DHCP servers, I'm using two different DHCP servers, and I have configured a scope 192.168.1.0. So when the first client will send a request DHCP discover message, so the DHCP server is offering 192.168.1.1 as the first IP address. But when the first client sends the request to the other DHCP server to get an IP address, so the second DHCP server is offering 192.168.1.254. Is it possible that two different DHCP servers sends two different IP addresses? Or if they can send these different IP addresses, what's the reason behind it?
Maybe two different scope are created into the two DHCP server.
No, basically I'm telling you I'm using two different networks with the same number of computers, but I'm using two different DHCP servers. So on one server I'm configuring the 192.168.1.0, on the other server I'm using the same scope. But the one server is sending 192.168.1.1 as the first IP. And the second one is sending 192.168.1.254 as the first IP. So there is a difference between DHCP server operating system. If your DHCP server is open source based, so then it will start assigning the IP addresses in the descending order. And if you are using some vendor specific operating system like Microsoft Cisco, so then the DHCP server will start assigning the IP addresses in ascending order. So this is a little difference. If you have Linux based DHCP server, it will start with 1.254, then it will lead 1.253, then 1.252. If you are using Microsoft or Cisco, it will start assigning the IP addresses from the first IP address and keep on assigning in the ascending order. Is there any other special use addresses? So this one is reserved for example and documentation. So have you ever seen 100.64?
No.
No. So that is called as carrier grade NAT.
Where it is used?
Service providers use it. It is called carrier grade NAT. So it starts from 100.64.0.0 and from 100.64 to 100.127.255.255. So this range is called as carrier grade NAT addresses. So if you want to check your public IP address, while using the mobile data. So you will see some IP address from this. So it is called as
I didn't
carrier
get it.
grade.
Oh, where it used? Sorry, I missed it.
When you are using your mobile data, and then if you will see your public IP address, or so then it will show you this the IP address from this carrier grade net. So most of the service providers are using it. Okay, today we'll keep up to here. Okay, let's quickly discuss class D and E, and then from tomorrow we will start from IPv6, and then we will discuss some more stuff. So we'll discuss IPv6 addresses, and I'll show you how we can configure those IPv6 addresses. So class D, 1110 is fixed, and then 000 to 1111 is fixed, and then it is 110 is fixed, 111. So this range is 224 to 239. So if you see these addresses in the first octet, so then it means your addresses are the multicast addresses or class D. Class D address, class D is used for multicast. So what is the subnet mask?
Mask 30.
There will be no subnet mask because each IP address represents a multicast group.
Mm.
So 224.0.0.0/16. So it is called as local scope. Local scope or within the same subnet, well-known multicast addresses. Like 224.0.0.1. Why we use this one? So this is all hosts on a subnet. So this one is all routers on a subnet. All OSPF enabled routers. Then we have a second range which is 224.1.0.0/16. So this is internet scope. Well-known multicast addresses. Then we have another range which is 232.0.0/8. Source specific multicast. 239.0.0/8. Locally administered. Locally administered within the organization or something. So you can call it as private multicast addresses. Then we have class E. So class E is if all the first four bits are fixed to 1. Two 40 to 255. So this is class E. Again, it remain undefined. So we are facing the lack of IPv4 unicast addresses. So that's why we are moving towards IPv6. So before IPv6, there was a project IPv5. So in IPv5, the size of the address was 64 bits, but then they see the growth of internet, and then they assume that after some time those addresses will finish as well. So that's why they doubled the address space to 128 bit and started the new project IPv6. So 255.255.255 global multicast address. Oh, sorry, global broadcast address. But nowadays its scope is link local. It routers do not forward the traffic for 255.255.255. That's why if you want to do the broadcast within your network, so then you can use this address. So from today's discussion, if I want to send a packet to all hosts on a network, so what are the possible options? To send a message to all hosts on a network. So what are the possible options? I can use global broadcast address. I can send the message to 255.255.255. The second option is I can use all hosts on a subnet multicast address. It means I can send the traffic to 224.0.0.1. Again, all hosts will receive it. The third option is I can send a network specific broadcast. Let's suppose my network is 192.168.1. So I can send it to broadcast ID 1.255. So these are the three options available if I want to send a message to all hosts on. So from IPv6, there is no any concept of broadcast. Why? Because if we want to send something to all hosts on a network, we can get the same results by using this multicast address. So that's why instead of using broadcast in IPv6, we get the same or results or same communications by using the multicast addresses. So that's why there is no any broadcast in IPv6. Anyway, we will discuss it tomorrow. So any questions from today's lecture or anything related to the training?